Hello there, and welcome to another Science Saturday. I'm your host, Noah Mugen. I hope you've had a wonderful, spooky October, and we're glad to have you back. Today, we're going to be delving deeper into the science of chemical reactions and how they produce light. I'm going to quickly go over the materials that we'll be using today, but don't worry if you don't have all of them. It's easy to follow along. Today we'll be using antacid tablets, Glowsticks, a glass, and water. Halloween always makes October such a fun time. It's so fun to see everyone dressed up in their costumes and walking around at night with all the cool decorations. One of the most common accessories on Halloween, of course, is the glow stick. All you have to do is crack it. You get an instant source of light. It doesn't even produce heat. And actually, how glow sticks work is a chemical reaction, which is what we're going to be going into today. If you remember our video on the digestive system, you should remember chemical reactions, which are when a substance is changed into something else by changing the chemicals it's made of. For example, plants go through a chemical reaction called photosynthesis to create their food, in which sunlight is used to convert water and carbon dioxide into oxygen and glucose, a sugar which they can use for energy. And like photosynthesis, all chemical reactions need some energy to get going. This necessary energy is called the activation energy and can be found in various forms. One of the most common ways to get activation energy is through heat. The hotter something is, the more molecules will be vibrating, and the more thermal energy they will have to start the reaction. And again, if you remember our past videos on heat, thermal energy is just how fast the molecules are vibrating, pretty much. So the hotter something is, the more its molecules will be moving around, which also increases the rate of the chemical reaction by making sure that they bump into each other more often and with a higher chance of bumping into each other in the right way. We can demonstrate the effects of energy on a chemical reaction with a simple experiment using two glasses, antacid tablets, and water. Fill one glass with hot or warm water and the other glass with cold water. Now, we're going to drop one antacid tablet each into the glasses. If you remember from our previous videos, an antacid tablet will react with water in a chemical reaction to produce gas in the form of bubbles. Now, how do you think the rate of the reaction is going to change depending on the temperature of the water? Well, let's find out. Remember, this is the warm water and this is the cold water. And you can see bubbles are forming much more quickly and in greater numbers in the warm glass as opposed to the cold glass. This is because the water in this glass has much more energy. As such, it's able to many more molecules of the antacid tablets and the water molecules have the necessary energy to start that chemical reaction. In this glass, however, the molecules don't have as much average thermal energy. As such, not as many of them will have the needed energy to start that chemical reaction. The heat energy in this glass is increasing the rate of the reaction. Now, much like the antacid tablet and water, glow sticks rely on a chemical reaction. Most glow sticks are made up of two solutions, one with hydrogen peroxide and the other with phenyl oxalate ester and a fluorescent dye, which gives the color. They're usually separated by glass. When you crack the glow stick, the two solutions are allowed to mix and the chemical reaction begins. There are multiple signs of a chemical reaction. These can include production of a gas, like with the antacid tablets in the water, production of a precipitate, which is a solid or little powder that forms at the bottom of a container after the chemical reaction is done. There can be a change in the color, there can be a change in the temperature, there can be a change in the smell or taste of the chemicals, or, like with the glow sticks, there can be the production of light. And much like the antacid tablet in water, we can show how energy will affect the chemical reaction of a glow stick. For this, you're going to need 2 glow sticks, 2 glasses of water, and water. Again, fill 1 glass with warm water and 1 glass with cold water. Make sure to remember which glass is which, of course, since, they look the same. Now, crack 2 glow sticks and place 1 in each glass. Take them to a dark area if you need to see them better. Now, watch the light intensity of the glow sticks. Over time, you should see that the one in the warm glass is a little brighter than the one in the cold glass. It may be not by much, but you should be able to see it. I'm not sure if it comes out in the camera, but this one is a little brighter than this one, especially once they're in the warm or cold water, respectively. Now, you're going to leave these out to sit for a while. Once you come back, you should see a stark difference. And now, after several hours, here we are again. As you can see, the glow stick which was in the warm water has dimmed dramatically. It's not nearly as bright as it was. However, the glow stick in the cold water is still fairly bright. Still not as bright as the warm water glow stick was when it first started out, but this glow stick's brightness has not decreased much at all. Why could this be? Well, the warm water allowed this glow stick to glow very bright. It gave it a lot of energy for its chemical reaction when it began. However, since that chemical reaction progressed so quickly, it ran out of materials much faster. As such, at this point, its chemical reaction has gone so much that the reactants aren't they aren't as in the glow stick as much as they were in the beginning. As such, less reactions can happen now, and so it's dimmer. In this one, the colder water didn't give as much energy for the reactions, and so they progressed much more slowly. As such, there's still lots of reactants left in this glow stick, which allows it to maintain a steady glow. And that's how glow sticks work. A chemical reaction occurs inside of them to produce light, and like all chemical reactions, its rate can be changed by its temperature. Well, that about wraps up another Science Saturday. I had fun learning about chemical reactions and glow sticks, and I hope you did too. Stay safe, have fun, and I'll see you next month. Bye-bye.